All right, welcome back. We are INFR3110. That's Game Engine Design and Implementation of the Fall 2020 semester at Ontario Tech, and it's week 4, part 1 of our broadcast. It's plugin and DLL day. And it's always a point of consternation for students when they first do this, because it's like, wow, we're making a plugin and we're using two different technology stacks, C++ plus Unity. It's a lot. And that's why we kind of present it over this week and next week. So just to say what we're at, this week we're at week 4, and we've just finished doing our checkpoints. So that's why we're at 422 right now. All of our checkpoints are done, and I've given out a in-class exercise for a bonus, which is to complete the little DLL in the PowerPoint that I've presented here. All right, so that's what this thing is. Last week we had a group assignment 1 details. Our semester project details are out there, and we talked about game engine architecture and all that kind of stuff. Your group assignment part 1 is due this Sunday, which is what this part says. Due Sunday at midnight, so that's when it's due. And that includes one portion of a completed game in Unity, and the game is what it's going to be is a level editor. Right, so one part of the level editor is due this Sunday, and it's worth 30% of your of the overall mark for the assignment 1, group assignment 1. Okay, the other 70% of it is due the following Sunday, so that would be the Sunday of Thanksgiving weekend. So hopefully we won't get into the beyond that, and you'll have a chance to actually have some time with family and friends. And we're doing a plugin today. I'm hoping to hit a couple of design patterns so I can help you with your assignment. This is what I really want to do. And then next week we're going to hit our midterm. Our midterm test is a practical test. I will release it on Monday, and you'll have from Monday until Friday to get it done. Next week, during this time slot, there is no formal lecture. So in other words, if you look at the time slot for next week, it just says midterm practical test. So what that does is it allows us to do things like get together. I still will be here, but I'm not going to have a formalized lecture. I will talk about more things for your assignment number 2. I may do a recording, depending on, I'll let you guys guide me on the thing that you want me to do, and I'll just do a recording based on that to help you with your assignment, group 1 assignment part 2, which is what I'm hoping to do, or anything if you're working on your midterm test, that's what I'm going to look for. Attendance obviously is not required. It's not mandatory next week. So if you want to work on your midterm test and you've left it to the last minute or whatever, then yeah, I'm thinking that I probably won't see you next week. But I have a feeling that some of you may come on and ask some questions and all that kind of stuff. The following week after next week, we have a study break week. So there's no classes after next week for a week. And then we come back and we're into the second half of semester, which is the bulk of the work that we're going to be doing this semester. Okay, so let's get to it. Let's talk a little bit about what the heck are plugins in the first place. So really, if you think about it, I want to add a specific feature, and sometimes I'm limited in terms of what I can do with Unity. Maybe I want to run something on the C++ side. I want to run something native. I want to add in my own little component that Unity possibly can't cover. Or maybe what I want to do is I want to combine something that I already have and kind of connect it to the Unity side. A lot of times we use things like loaders, loggers, networking, all those kind of things we can connect through a plugin. And that's why it's a kind of an essential skill for you guys as you're learning game development. So there's 2 types of plugins that are mentioned here. One type is a managed plugin. That's on the C# side. C# is a managed environment, right? And native plugins, which are on the C++ side. So it's a non-managed environment. And what that means is you can have unsafe code, you can have pointers, you can have all those kind of things. And some people really love to work and quick algorithms that might work a little bit better at a lower level than, let's say, on Unity. From a management perspective, if they want to do things like they want some kind of efficiency gain that they're doing with, let's say a coroutine or something else that needs to be lower level, we use a plugin for that, and a bunch of other things that you might be able to think about as well. So we're going to be using plugins in Unity 2020, and the reference for that is down in here. So if you ever want to look and see how that's done by Unity, that's where we take this stuff from. in order for us to make a plugin, first we're going to write it on the C++ side, and then what we're going to do is we're going to use an interface on the C++ side, a wrapper that exposes the functions that we want on the C++ side so that they're available on the C# side. That's the idea of plugins. So C++, you write some simple code, and then you expose several functions, and those functions will be available, and it could be even other things. If you want to expose things like variables as well, anything like that, any kind of data that will be available on the C# side. A good example of this is when I did this several years ago now, we made a Voxel Editor. So we kind of made an idea of a little Minecraft game, my partner and I. And what we did was we made a binary loader and saver. So we were able to save out all the entire voxel map by one press, and then load it back into Unity. And that would be way more effective on the C++ side, as an example, than we would have done at that time with Unity. Now Unity's tools have improved as well, so you're going to get pretty good gains on the Unity side. So I've asked you guys to follow along here. I'm not going to go through each of the slides here to tell you what to do. This is just a step-by-step on the PowerPoint deck here that tells you to go from slide 9 to slide 51. So for people who haven't done this yet and that are going to do it later, or let's say you missed class somehow or something like that, or you haven't had a chance to finish it, I'm going to take you all the way down to slide 51 here, where it says, hey, now let's take it to Unity. But I'm going to show you my example here on the C++ side and explain some of the structures that you need. Okay, so let's take a look at that now. So I'm going to kind of drag up this lesson. So if you notice, I've got the same structure that you may have seen here on the C++ side in the PowerPoint deck. Okay, so there's several things that we see here. One to note, when I make a plugin, all right, I'm not making an executable. So notice I have a release. I'm in release mode here in C++, right? And one of the challenges when we make a plugin is there's a lot of little piece parts to it. So the first thing I had you guys do in Unity was write a little struct. Okay, so let's talk about, or actually in C++. So if I go to my vector2 struct, so here's a little struct. It's just a couple of floats, an x and y. And you're like, why a struct? Because sometimes what we want to do is we want to pass in positional data, or we want to pass in a width and height kind of data. Now, I've made it a vector2. You can make it a vector3 if you want to and extend this. It's not a big issue. Okay. The challenge is how a vector2 in C++, how does that translate into a vector2 on the Unity side? Well, it doesn't actually. You have to kind of create those structures. Think about us as serializing our data in a DLL. And what I mean by serializing is taking our data, creating a library, if you will, that's in a compressed format that I'm loading into Unity. So I create the library on, as an example, on the C++ side. It's runnable only in Unity. So it's not something that you're going to go through main. Main is literally there just as an entry point. It's going to be, like you see here, blank. It doesn't do anything. Why? I'm not going to run my code. It doesn't produce an executable in release mode. So let me show you that. So one of the things that I've asked you to do once you've made your vector2, right, is you need to use this somehow. And I've created a very simple game object, super simple. And the simple game object, what it does is it uses a vector2 and an integer, right? And I call it a vector2, but it's actually a vector2D of my own making in C++. Okay, so that's what it is. And it stores it as a member variable, m_position. On the private side, this is your declaration for your game object class. And let's for a second, I want you to turn a blind eye right now to this plugin API thing. If you don't know what that means, it's okay. Let's just close your left eye when it comes to what that means. Just look at this part. So for here, all I'm doing is I've got a constructor for a regular game object. I've got some getters and setters, a get accessor and a set mutator for both on the C++ side here. And I also have a getter and setter for position. So ID and position. Imagine if I have a handle from my game object and I have its position. That's it. And only in 2D, not in 3D. Okay. Again, you would extend this to 3D if you wanted to make use of it. Okay, so what does it look like on the C++ side, on the CPP side? So again, that was the declaration. Here's the definition. So notice that we, when we instantiate a game object of type, or an instance of game object, we set the ID in the position. That's what we're doing here. And we're actually using these setters that we've kind of established. And you can see that this is nothing new. There's nothing that's spectacular here in terms of C++. One thing to note is that I'm not using a constructor for my struct. Okay, so there's no constructor. I'm not accessing the default constructor here. All I'm doing here is I'm accessing the member variables directly, and I'm assigning them values from the set position mutator. Okay, that's what's happening here. Okay, so that's the one thing to note. When you try and do something like a constructor, or if you're trying to, you're going to try and pass stuff in here, if it becomes anything like anything that where memory is being managed, you might have some really weird errors come back at you from Unity. And we'll talk about some of the variables that you can pass from the C++ side over to the Unity side. In other words, I'm talking about data types. So, for example, integers, integers are integers in any language. They're pretty much the same for the most part. You know, on the Unity side or on the C++ side, there's an equivalent, integer as an example. But strings are a different animal altogether. Strings really are an array of characters, right? So the way you would pass that back out to, from the C++ side out to the C# side, you'd have to marshal that array, marshal the string a little bit. And we're not going to go into too much of marshalling. I'm hoping that Nicholas can kind of handle marshalling for you and how that works, especially if you have things like arrays and all of those kind of things, other memory structures, right? They're more difficult beyond primitive data types. Primitive data types like floats and ints, not a problem. I'm going to show you structs today because I think structs are very useful. But you can also do everything else you want. If you want a whole array of data, which is what I did with the Voxel Editor, then really at the end of the day, it doesn't matter. You can just send it as a bunch of bytes, right? And as long as it's got, it makes any sense, we can save and load that data. Okay, so really one consideration when we make a class for the plugin is what kind of data is going to flow back and forth across the plugin. Is it going to be primitives? You're going to be good. If you're going to make it more complex types, classes, no. You need to serialize those classes and deserialize them when they come out of C++ and back. In other words, I'm going to have some kind of setter that takes a bunch of little values, or I'm going to decompose the class into their primitive types, and then I'm going to send those primitive types across. When they come into C++, I'm going to deserialize them. So in other words, compose the class structure that I want in C++. And then after I've composed the class, it's almost like I'm encoding and decoding. Then what I'm going to do is I'm going to take those elements, do something with them, and maybe if I need to, send them back in a deserialized format, or back as data types or structs. Okay, so that's how the idea between passing data between C++ and C# works at a high level. So this is the game object class. Doesn't do much. It has a couple of things. There's no other methods that are tied into this or anything like that. In order for us to connect and have a plugin at all, we have plugin settings. And when you look at these plugin settings, we had some students that asked me, what the heck are these hashtag if not defines things, right? And what do they mean? These are preprocessor commands, my friends. So for people who've never seen them before or have seen them only one time, C++ and actually so does C# and other languages have something called the preprocessor stack. And what happens is as the compiler goes through and starts reading these files, it goes through and looks at these preprocessor directives, these commands here, right? So things like pragma once, you may have seen these before. It means don't include this file more than once when I compile. But that pragma once is actually a very Microsoft specific compiler, the MSVC, which is Microsoft's Visual C++ compiler that's built into Visual Studio. Okay, so it's very Microsoft or Windows related. If I want something that is cross-platform, I need another guard. I need to guard the fact that I might load in my .h file a couple of times. And so what I have is a cross-platform guard, which is this. If not defined, it says, hey, I'm going to create like a macro. It's going to be called, or I don't know, a label, if you will. This label is called plugin settings. If the label is not defined, then define it. Okay, cool. If it is defined, skip this whole part. Don't do it. Don't include this again. That's what if not defined, how it works. If not defined, this label, define it. Okay, cool. And then this is where it ends the definition. Then, so if I've only loaded the plugin one time, that's fantastic. Now I've got these other preprocessor commands inside of this one. And what this does is says, okay, if defined, if something is defined, plugin exports. Not if not defined. If undefined means if not defined. If defined means I'm looking for this to be defined. And this is usually defined in the preprocessor portion of your properties for your project. I know it's a little complex, but we'll get to it. So if it's defined, cool, then I want you to define something called a plugin API. The plugin API, all it is a little macro, right? Or a definition of Dll spec DLL export. Instead of you writing Dll spec DLL export, you don't have to write it. You just have to use plugin API. And plugin API represents Dll spec DLL export. That's what it is. Notice that Dll spec Dll Import is grayed out because I haven't included that part in the preprocessor configuration of your project properties. Okay, so that's grayed out. Usually we don't use too much of this anyway. It's usually DLL export that we use. Okay, and then there's another one. So if it's one of these two, if it's plugin exports, then you want plugin API to represent this. If it's plugin imports, you want plugin API to represent this. That's all it does. It's just a switch for two different kinds of specifications, depending if it's an export or an import. Okay, but we're making a native plugin, so it's always probably going to be an export. That's one thing to note. This other one, where this other else case is, think about this as another case. If it's something else, then just make it so that the plugin API represents nothing. That would be an error if I had something like this working out. If you got to this point, then something went wrong up here. That's what this means. Okay? And you would get an error like no entry point or something like that in Unity. So first we define this plugin settings. And when you do, if you look at the PowerPoint document that I shared with you, that's here. And I talk about how you basically, it's further up here, I say that it kind of lights up. When everything works out, the plugin exports part lights up. Otherwise, it'll be white. It'll look different. It'll look like this. See how that is white color? And then when you connect it in your project properties, it'll look like it's lit up like this, like a different color. This in Visual Studio 2019 tells you that it's connected to your preprocessor, the properties in your preprocessor stack on the in the configuration properties of your project. So where is that? Well, if I right-click here, or if you go to Project Properties, I'm just going to go to the bottom here where it says Properties, or you press Alt-Enter. That's also a way of getting to them. You can see that if I go to my C++ section and I go to preprocessor, then I have something called different options. Why? I'm looking at all configurations right now. All configurations. If I wanted to look at the current configuration, you can see that I'm in active release mode. And then you can see that no debug, that's on. A console window is on. And I got this plugin exports. See that plugin exports right there? I added that in. So if I go to edit here, you can see plugin exports is actually in there. Plugin exports lights up plugin exports in this C++, this plugin settings.h file. That's what it does. It lights it up because it connects. It detects. This preprocessor command says, hey, it exists in my project. If it exists, then plugin API represents Dll spec DLL export. That's what this does. Okay? So now this is in active release mode. Okay? And you can have different configurations. Here's one. If I go back to general and I slip out of active release mode, as an example, let's say I go back here. Instead of release mode, I go into debug mode, right? Right now, all modes lead to DLLs. That's what they do, right? And the way they lead to a DLL is back into the project settings. You can see that in general, it creates in the configuration type a DLL, right? That's what it does. If I want my debug mode to create an executable so we can test it, then I would change this only in debug mode into an executable, like so. Okay. Otherwise, if I press apply, let's press apply here, and if I go back to release mode for a second, and then I check my properties, okay, you're going to see that in release mode, it's still a DLL, a dynamic link library. DLLs cannot be run inside of your Visual Studio. You don't see a console window that pops up. You'll have an error, actually. So a good example of that would be if I run this thing now in release mode, right, you'll see an error that pops up like this. That's normal because you cannot run a DLL. You create a DLL. It creates an output. The output is a DLL, not an executable. However, if I go back to debug mode, and if I uncomment out the stuff in main, I commented it out because it's just an entry point. It's just testing, right? So if I uncomment this out, one part that I talked about in the inside of our code is run main and have this as a testing bed, a test rig, if you will, to test out your little game objects, right? So let's just uncomment that. There we go, game object. And if I want to run this now in debug mode, then it will run, right? Because I'm creating an executable. And what it does is it just tests some test data. Game object ID is 1. Game object's position is 100, 200. So this is testing the fact that my game object works and also my vector 2D works as well. That's what I made this little thing for. However, in this mode, in debug mode, because I've changed my configuration inside of my properties, right, to run an executable, it will not create or modify the DLL. The only time a DLL is created now is in a place where it says in the configuration type DLL. So that's the main thing you have to worry about here. So let's go back to release mode. But before you do that, let's comment this out because in release mode, this will not compute. So let's just comment it out. In release mode, I'm going to go back to release mode now. And when I do this and I can't run it, the way to build this is to go to build menu and go build solution or press Control Shift B. Control Shift B is a quick way, and on the bottom left you'll see build succeeded. That's the only way that you know it's been built. Another way to check is once this thing has been built, I'm going to go back to the other stuff in a second, the wrapper. But if you right click on your solution here, and if I go to Open Folder in File Explorer, you're going to see this come up. All right, this is your solution. You want to go into the x64 folder. This is just inside of the folder for your project, your whole solution. If you go into x64, there's two folders now, a release and a debug folder. If I go to the release folder, you're going to see a DLL. There it is. Look at that DLL. That was just created because I just ran it, right? 443, which we're running really late. I want to take that DLL, and that's the one I'm going to use in Unity. Okay? We're going to get back to this in a second. So I've made my DLL. That's how it's been made. Notice this other stuff here, I don't care about it. This is just intermediate level stuff that gets created so that my DLL gets built. I don't need it in Unity, just the DLL by itself, just this one file. Okay, next. What the heck is a wrapper? Well, a wrapper class, really what it does is it instantiates game object for me, right? I can't use my main because main is something that's going to be the entry point if I was going to create an executable. So what I need instead is somehow to expose anything that I want from the C++ native side to Unity. So here I just defined a bunch of functions. You can have more than one wrapper class. If you have more than one class you want to connect to, you can have more than one wrapper. And you can create more than one DLL inside of Unity. You don't have to just have one. You can have multiple DLLs, right? Each library can represent one class. Each class can have its own wrapper if you really want to. Or you can have multiple classes and one massive wrapper. It's really up to you. And you can name these functions anything you want, even if they're not related to the class. So example, these are called getID, setID, getPosition, and setPosition, but the class I want to unwrap on the managed side, on the Unity side, it's going to be my game object class, right? But these are just called whatever I want. So I can expose and call these things anything I like. The challenge, okay, number one, notice that I have to prefix these things with plugin API. Why? Because we're using DLL, Dll spec, a DLL export. That's what we're using here. That's what this plugin API does. It prefixes the type of data, and it's telling C++ that, hey, guess what? Externally, we're going to pass this to a managed environment, That's what's happening here. And we're going to change this integer here, potentially, right? We're going to pass this over somewhere else. That's what this thing is doing, right? It's kind of flagging these or check marking the functions that I want to make available on my C# side. That's what these things do at a very high level. The wrapper CPP side, what I do is I make my own instance here in the global space, right? Now there's many ways to do this. You can use a singleton, you can use a static class game object or something else, right? And here what I'm doing is I'm just accessing the data the getters and setters inside of these functions. The functions are the ones that are going to be exposed. I can have other things inside of these functions too, right? Other things that are running. At the end though, all I care about is connecting the thing that I'm exposing, my function that I'm exposing. Think about the function that I'm exposing in the wrapper as a middleman, if you will, or a delegate between my native side, which is C++, and the Unity side, which is going to use this interface right here. Okay, that's what it does. So between native and managed, that's what it does. Okay, so that's how this looks. That's what this stuff does. And so when I make my DLL, it's going to have these endpoints, this API. That's why it's called a plugin API. API stands for Application Programming Interface. And so that these function names exactly written this way are going to be available to me on the C# side. Let's code it. Okay, and then we'll make a little GitHub repo later for everyone. I'm going to run a little late today, guys. If you have to run away, I totally agree. It's okay. I'm going to produce a video for the stuff that you need. It's going to be up on YouTube anyway. You can watch it at a later date, but if you can stick around, that's great. Okay, so we've got all the way down to the bottom now. We have my DLL at this point, and hopefully you've figured out your issues. A lot of them have to do with just what I just showed you here. But now we want to bring it into Unity. So I have a Unity project that I've created, and notice that I have in my little Unity project nothing in it, just a main camera, a directional light, and a game controller. There is nothing else in here. What I have though is a structure that's important to note. Now I use, this is my layout. You might be used to something that looks like the default layout, like this. That's fine. I think this is an inefficient layout for what we're doing. But if this is where what you're used to working with, it's totally fine. You don't need to make it more complex than this. However, I prefer a tall layout to start, which looks like this. Okay, and I also reduce this to a list. Okay, now I've called my scenes folder _scenes, so it comes at the top. My scripts folder _scripts, so it comes at the top. And then the required folder for us, whenever we want to have a DLL work, is the plugins folder. You must call it plugins, just like this. If you don't have a folder like this, you'll never connect to the non-managed side. Okay. I've created a game controller, which is an empty object, and I've put it inside my hierarchy. It doesn't do anything, literally, right? And inside my scripts folder, I have an empty plugin tester script that I've asked you guys to make. I'm going to double click here and open it up in Visual Studio, and we're going to code it together. This is the last part of what you need to do for your in-class exercise. Let's do tomorrow. All right, so you can see that the plugin tester does nothing, right? And the thing that we want to do here, I'm just going to move some of these windows around so my reference is good, right? The thing that I want to do the most after we've got the plugin in there, right, is we want to start scripting out what this thing is going to look like. So the first thing I want to do at the top of the plugin tester is mention kind of a little constant string, which is going to be called DLL name. So this is going to represent my DLL name. Okay? Think about it as just a constant. I'm going to call it, it has to be called the exact name of my DLL minus the extension. So that means that if I go back to Unity, and if my DLL was called in my plugins, which I passed in here, I just dragged and dropped it in here. That's all I did. From my folder, my file explorer, into Unity, I just dragged and dropped it. If I click on this once and click on it again, I can copy this, the name of my DLL, and when I go back into my script here, I can paste it in. It has to be the exact name. There cannot be a variance in any way. Okay? Do not put .dll. That would fail. Okay? So that is the first thing. Are you with me? We're in Unity. Check marks if you're with me. X if you don't know what the heck I'm doing. And if you don't know what the heck I'm doing and you stopped at 420, check marks. It's totally fine, man. Don't panic, right? Remember that we're being recorded, so I'm going to hopefully be able to do this. And I'll also produce an example up on GitHub after we're all done. So you can have something to compare mine with yours. In fact, you'll be able to download my thing and try it out, and it should work. So that's the first part. So I'm connecting to this, is what this is saying. Next, we need to use some configuration. Okay, that's the first part. Some configuration. All right, and the configuration that we want to use for this, if we think about it, is the first part. I'm going to go DLL Import, my DLL Import, and I'm going to do DLL name. So I'm going to import from my DLL, right? And then I need to match up whatever was in my my external functions, right? I want to match them up here. Okay, so what I mean by that is, I want to make it private, static, extern. That's the syntax we're going to use. If I want to get an integer for my get ID, okay, that's the first one. Let's try get ID first. I want to put int. That's what's being returned back from C++, and we're going to call it exactly the same name as it is on the wrapper side. So if I go back to my my project, right? Notice that we have a name in the wrapper called get ID, right? You need to call it the exact same name, get ID. So I'm just going to grab this part right here, or just the get ID itself if you want to. If you're a copy-paste problem, go back and paste it in, right? Get ID. So this get ID is the thing that I'm going to get from my DLL. Let's just do one for now, all right? I'm going to get rid of this for now, okay? So I don't care about my start function whatsoever. All I care about is my update. And what we're going to do is a very simple thing. We're just going to say, in my update, we're going to do if input.getKeyDown. Input.getKeyDown. We're going to use keycode dot, let's say s, right, for my little simple function, right? Or let's suppose this is the ID. We can get keycode.I, whatever you want. And what I want to do with keycode.s is I want to do a debug.log for now. That's all I want. Debug.log. That's going to call the function getID. Pretty simple, right? So, and this is the Unity side. All right. So all this is doing is I'm connecting to my DLL. The DLL's got to be in the plugins folder. I need to have this directive. This is an attribute, if you will, or a decorator. It decorates the function name that's coming from the DLL, and it has to be the exact same function name. Okay. And then what I want to do with this is I want to take this and I want to test it by doing this. So save. I'm going to save my function. I'm going to go back to Unity on the Unity side, and then I'm going to run it. If everything goes well and I didn't mess up, it looks like I'm okay for now. If I press the S key, right, in Unity, then I should see somewhere. Let's just try this again. I'm going to go back into, stop Unity for a second. I need to go back into my general in my console window. And in my console window, I want to put my console window somewhere that I can see it. I don't have it here because I changed my layout. There it is. This is where I want it to go, right? So I want to press the S key and kind of have it work in here. One thing to note is, the other thing that you have to make sure is you have to connect, which was what I haven't done, my script. This script here has to be connected to my game controller, which has not been done. So add my plugin. There we go. That's probably why it didn't work. Let's try it again. So we'll run. And S. Hey, look, it says 0, right? Why does it say 0? Because by default, if you remember, back in my DLL, right? If I don't specify what my ID is in my GameObject.h, I specify that the default value for the ID is 0. So that's why I'm getting 0 back out. Cool. Let's set the ID now. How do I do that? Going back to my Unity side. I'm not changing my DLL. I'm just going back to my Unity side and communicating with the C++ side. So here what I'm doing is I'm doing another one of these. I'm going to say, hey, DLL Import, DLL name, right? And I'm going to say private, static, extern, and this time it's going to be void set ID, right? I'm pretty sure was what I put, and I'm listening for an integer, right? So it's got to be an integer that I have in here. I'm defining the same structure. So again, if you forget what it is, you can always go back, as an example, into set ID and check and see what it is. So let's take a look and see what that is. You can see that set ID takes an integer, and I'm using a variable called ID, but it could be anything. So I'm going to say int ID. So set ID allows me to set my ID. Let's set it here. So when I press the S key, I'm going to also set the ID and get it back. Let's do this. So it'll do a round trip here. Okay, this is the first part. So the way it works is I can say, okay, well, let's set ID to some number. Let's set it to 420. All right, just because people are interested in 420, we stopped at 420. What the heck? That's an integer. It'll go out and it'll come back as 420. That can't be random if we get that back, right? It can't be 0. 0 could be random. Maybe it's a mistake. 420 is not a mistake. It's very deliberate, right? So now let's go back and see if we get that. So going back to Unity, I'm going to stop running, and then let's rerun it again. And when I do this and I'm running, and if I press S, hey, I get 420 back. That means, in this case, I've gone out to the managed side, to the non-managed side. I've sent data across to the C++ side, and I've gotten it back. That's how that works. That's how that whole sequence works that I've just done. So out to the C++ side and all the way back, a round trip. But how do I get structs? Well, Unity doesn't know what a struct is on the C++ side. I mean, it knows, but unless I make it, because a struct is my own data type, right? I need to help Unity understand what a struct is. So let's make it here for myself. So I'm going to create a little struct, and I'm going to call this struct vector2d. There is no vector2d in Unity. It's only a vector 2. So we want to define our struct, because remember we're talking about serializing and deserializing data, right? I want to just do the same structure. In fact, I want to say that it's a float, right? And let's make it public. We'll make it public like it normally would be, right? And the same thing with my x-axis, right? My y-axis. There we go. Public float, x and y. Okay? So that's your vector 2. We need to define what this is to help Unity along. Because otherwise, when I get a struct back from C++, it doesn't know what it is. I need to help it. Okay? Let's do the DLL. The DLL is going to look different. All right? So the DLL is not going to be just a DLL import anymore. I want to define some other structure, right? And if I start talking, if I do struct layout, that's what I want. My struct layout is going to be, and there's a bunch of options, right? If I press Control Space, I want to do a sequence, a sequential, whatchamacallit, it's basically going to be a sequential struct, right? So it can't be this, right? I need to still get my DLL, right? So notice when I do struct layout, right? Struct layout has a bunch of different things. Struct layout dot, and if I go do struct layout dot, it doesn't do anything. If I do this dot, it doesn't do anything. But if I do this, you can see that I have structure. One is the character set, int is the packing type, and the size, if I want to put the size in there. So let's look at struct layout and let's see what happens when I want to pass a struct. And I want to show you this, because you look it up, you're going to look up different things when it comes to marshalling a struct, right? So I want, so again, if I was to look at marshalling a struct, so again, struct layout, right? And notice where it says layout kind sequential, there it is. If I just looked up struct layout, this is what I need right here. Okay, that's what I need. So layout kind sequential is what I need. layout kind is sequential, right? Layout kind sequential. Dot, come on. I'm putting it wrong. Layout kind with a capital L. Layout kind sequential. It's an enumeration. That's what it is. All right. That's the first part, layout kind sequential. And I need to put in the thing I'm getting. So I'm going to say private static extern. And it's going to be when I get a struct back, I'm going to get a vector2d, this one, that I just defined, which is from the thing that I'm getting. I'm going to get a position, right? Get position, right? And that is my struct on the way back. Okay, I'm still not quite done though yet, right? So struct layout struct sequential, right? That's what I want. And I want to put this part, if I put this one part up here, what do you think if I did this? Do you think that's probably good if I did this? And if I did the DLL down here like this, that's what I want, right? So DLL import, DLL name, and I want this thing here to be my layout struct. I'm kind of defining what this is so I can connect to this thing. All right, I kind of went about it in a really weird way. But at the end of the day, I have to define what this is. Notice this says public, and it says you don't need this. It says X can be private, and that's why I'm getting this little thing. This is just my Resharp or C++ warning me that this can be totally private, and I'm good. All right, so this is layout kind sequential, and I've got DLL import, and I'm importing a vector2d. I've told it what it is, right? And let's see if I get this, what it's going to be. But let's put both of them together because we're running out of time. Let's do the other side. So I'll say DLL import, DLL name. I'm sure you've guessed it. Private static extern, and we're going to say that it's a void, right? Because we're setting something. Set position, and we're looking for float x and float y. Are you with me? Are you with me? So all we're doing is we're matching up. If you're with me, check marks, guys. If you're lost or you don't know what's happening, X's, and I'll go back. I want to kind of get you to understand this, and I'll talk about it one more time. Some people are with me, so you know what I'm going to do next. X's. I see a couple X's. Logan, I'll be with you, and I'll show you what that is. All right. So my set ID broke. I'm sorry, Logan. Unity is broke. Oh man. Unity shouldn't be broke. All right, so how does this work? So if you notice, this is the same thing as what I've done here. Notice how these are grayed out, but these ones are lit up, different colors, right? I haven't used these ones, that's why. Let's use them now. So, okay, so here's my set ID and get ID. Let's set, I want to do set position. I'm sending a positional data over to Unity, over to the C++. Let's make some non-random values, very deliberate values, like, I don't know, 3.4f and 5.7f. That's what I'm looking to get back from the C++ side. Now this is where it gets tricky, right? And when I get it back, I want to debug.log it. I want to debug.log, right? Again, it's going to be get position, right? .x for now. And I want to debug.log get position. It's pretty rough. .y. So I just want to get those two values back from the struct, right? So the struct get position, I mean, it's coming back. Get position is producing a values, right? I could also create a vector2 object here to get them back, because get position actually returns a vector2 object. It returns a vector2d object. So what I could do instead, and I will do this later on, is produce a vector2 object that has those values. But for now, let's see if we get this back. So I'm going to say save. Again, we're just doing baby steps here. And then going back out to Unity, and then we're going to run it again. And if everything goes well and it doesn't break, and if I press S, hey, we're good. We're booked. We're good. Look at how I got 3.4 and 5.7. If I can get 3.4 and 5.7, guys, I've got full, kind of like round trip. I'm doing a round trip from Unity to C++ and back. Right? That's my communication. That's your DLL for today. That's all I want you guys to do. That's it. So that should be your way of doing it. Let's clean this up. Let's make it a little nicer. Let's make it so we can make it do something. because right now we're not doing anything with it, right? I can send any value across to, as long as it's two floats, I can send those two floating point values across, because our DLL is X and Y. Okay, but what if I wanted to make it, you know, I've made a mistake. I want to make my DLL a vector 3 object, not a vector 2. Oh my God, I'm doing things in 3D, guys, and I made a big mistake. What do I do? How do I fix my DLL? That's another piece that we have to figure out. Okay. First, we don't touch this. We go back, we make sure it's not running, and let's stop Unity. Turn it off. Whenever we kind of put a new DLL in place, or we're going to replace this DLL with a new one, we need to turn Unity down for it to happen, because it needs to be re-imported. Or you can try and re-import it. Sometimes it works, sometimes it doesn't. So I'm going to turn Unity off here. Okay, so Unity's done for now. I'm going to go back to my code. I'm going to go back to my code on the C++ side. Here it is. And I want to rejig some of these things. I could do two things. I can make a new class of vector 3D, or I can modify my vector 2D. Let's make a vector 3D class. It's pretty simple. I'm just going to copy everything in the vector 2D class and add another character. All right, literally. So I'm going to go to my header. I'm going to add a new item, and we're going to call this a vector 3D. Vector 3D instead of 2D. Just like we did before, we have our pragma once, which stops our Visual Studio from including this object more than once, this .h. But we need to use cross-platform guards. So what that looks like is, if not defined, we're going to call it vector 3D. This is just a definition of what this is. So define a vector 3D and end if, right? And we can put a little bit of a comment there. Okay. So this is just saying anything inside here is what we're going to protect, right? And now I'm going to make my struct. My struct, right, if you think about it, it's going to have a name of vector 3D, just like we did before. And I'm just going to go and get some help from my vector 2D. It's already done. So I'm going to grab those two things here and go back into my vector 3D. Oh yeah, it's so hard. And we're going to change this into a float Z. So this is another struct that we're making now, right? I want to add my vector 3D, right, into my game object, because my game object is the class that I'm using, right? So back into my game object, I want to include vector 3D, right? And we've made vector, which I'm going to call our vector 2D, right? Position is vector 2D. I'm just going to not use the vector 2D part at all. So let's just undo that one. So I'm going to say, you know what? I've decided to make it a vector 3D. I'm not killing my vector 2D. I'm just going to make it so it's a vector 3D. So I'm just going to replace this with vector 3D instead. Just going to rejig this thing. Okay, something like this. And if I did this, then I got to fix my game object CPP side too, right? Because instead of a 3D, by the way, set position can't be only X and Y. Maybe it's got to be X, Y, and Z. Okay. X, Y, and Z. Get position, set position. Let's go back into my GameObject.cpp and fix it. So this has got to be 3D instead of 2D. Right? I don't need, I have to include the same stuff. So 3D's got to be included in here. M_position. It says it's going to be 3D. And this set position has to also match the signature. So it's going to be const float Z, right? As an example. And I'm going to do the same thing, M_position dot Z. So there it is. So I've updated my game object, and I don't need this anymore. I can get rid of that. I've updated my game object so that we have a 3D vector for position, not a 2D vector for position. This is the exercise today, guys. So to get you to understand the whole gamut of how to do this, right? How does this work? So we need to regenerate our DLL, number one. and let's take a look and make sure that things are good. I'm good over here. Now we need to update my wrapper. My wrapper can't be anymore with vector 2D. It's got to use vector 3D, right? So again, I'm just going to update my include. It's going to be a vector 3D. This has got to be the same thing. Float Z, right? I'm going to pass the 3D vector now, right? Because we're in 3D games. And let's update the wrapper.cpp, where I'm going to change this to 3D, right? And I'm going to get a const float on the z-axis, and I'm going to set position x, y, and z instead of just x and y. I know that's a lot of changes, but it's really not much. Not if you think about it. It's the exact same thing. I have nothing else to change because my plugin settings are like literally a file I never touch again. I do this once, and I never touch it again. All right? What I need to do is I need to build this thing. I'm in release mode, and I'm going to take a chance. Normally, I would test it in debug mode, make sure that everything's good. I'm not going to test it. I'm just going to, fix it because of time. So I'm going to press build solution. It says build started, build succeeded. Where the heck is my DLL? Well, I'm going to go right to my Solution Explorer. I'm going to go open up File Explorer, right? And inside of my x64 in release mode, I have my new DLL, and it's got the new timings, right? 5:12 p.m. We're running late. Thank you for sticking around, guys. I really appreciate it. We have that file for every time we create a DLL. We're always going to get a brand new DLL. It's going to overwrite this thing every single time. Logan. All right, so cool. So now that we've got this, let me just turn this down and bring up Unity again. So we know we had Unity somewhere, right? Let me bring it up. It's on my desktop in INFR3110, right? Here it is. And there is a it's got to be lesson 4 something or another. Let's see where that is. Sorry, let me just make sure I know where the heck that is. So I'm going to go to Unity Hub. There's Unity Hub. If you don't know where your stuff is, mine is OneDrive desktop, and I want to open it in Explorer. There it is. It's somewhere else. It's in Unity. And inside there, I have my Unity project. Inside of my Unity project, I'm going to show you how to do it now in the File Explorer. Instead of dragging and dropping in Unity, I'm going to go into Assets, into my plugins, and I need to delete the thing that's already in there. So I'm just going to go and take that stuff that's inside the plugins folder in my File Explorer and delete. And then I'm going to go inside of my project in my C++ project, right, in here, and I'm going to drag or copy and paste, not drag and drop, copy and paste from here to here. So this is on the File Explorer side. I'm showing you another way to do it, okay? If I deleted this from the left-hand side and relaunched Unity, it wouldn't find it again, and that's perfectly fine too. You can always try to re-import stuff. You can drag and drop it and re-import it, but sometimes that causes an issue. So I'd like to just turn Unity off and copy paste from my file system and then turn Unity back on it again, and it'll re-import it like this. It causes me a whole pile less errors. I'm just going to launch Unity again. When I do, watch over here what's going to happen. As Unity turns on, it re-imports this and creates a meta file. See, there it is. It's re-imported my DLL right now, and my DLL is brand new. I'm not done. I need to modify the way Unity sees stuff now too. So going back to my scripts, going back to my plugin tester, I know that my vector 2D is no longer valid. Let's change this to a vector 3D. And we're going to do a public float Z because it's got to match my structure on the other side. Let's change this to 3D. And let's make sure that when we set it, we set to a float Z out to back into the C++ side. Instead of setting position 3.4, 5.7, let's set it so that it is something else, 9.8. So I've got 3 values now instead of 2, and when I output it, let's output another value too. And this should complete the whole experience for us to show you the whole way you do it. And then we'll do a bit of a recap. Okay, so modified my struct. We kind of mentioned it as struct layout kind sequential, right? And we have the things here, the functions that match the wrapper on the C++ side. And all I'm doing here is sending data across and receiving it back. Let's change the number so we know it's not random. Let's make this number 911. All right, it's something crazy. And this number is different because we've added the 9.8. All right. Okay, cool. So let's save this. Now my plugin tester file is done. Let's go back to Unity, and if everything goes well, if we did things good, if we didn't mess up, if I run this, we should be good. If I press S, then, hey, 3.4, 5.7, and 9.8. We got all the values back from the C++ side. Now, this is where it becomes really cool. I want to take those values and apply them to an actual game object in Unity. And I can do that by right-clicking and adding a cube. I know it's not exciting, but when you run this thing, you can now see a cube, right? What I want to do is when I press the S button, it's going to take on the values of the floats that I get from C++ to prove to you that it's doing that. Okay, cool. The way to do that is to create in my game controller, inside of my script there, my plugin tester, let's make a reference to my cube up here, and it'll be public. So we'll call this public thing. It'll be a type game object. We'll call it cube. Not very inventive. This is inside the plugin tester.cs file. It's connected to your game controller. Then what I want to do is go back to Unity, and in my game controller, drag and drop from my cube to make a reference in the plugin tester's cube reference right here, like so. Now, game controller, which is using the plugin tester script, also has a reference to the cube. Cool. Let's go back to code. So when I press the S key now, I want to get these values. I can set position. Instead of just getting position here, what I want is for my vector3 object, my actual position, right? Let's see if that works. Can I get my actual position modified? So then what I can do is I can say that down in here that my cube.transform.position is equal to get position. Wow, is this compatible? Hell no, it's not compatible, because get position has nothing to do with a vector3 object. That vector is my own type, and position is listening for a vector3 from the Unity side. Doesn't work, right? They're not the same. So, worst case scenario, right? I can do what I did before up there. I can say I want a new vector3 object and pass in those values. Get position dot x, get position dot y, or I can also create a structure. Get position dot z. Okay, and that x, y, and z are coming from the C++ side. I'm creating a new vector3. I'm serializing, reserializing, or deserializing the data into something that my cube can understand, right? When I do this, and if I go back up to Unity and run it, and if I press S, then boop, there it is. Now I have full circle. Never mind that I'm getting data from C++, but it's coming back at me and I'm repositioning. So how can this work? This is a great example of how you do loading. Imagine if I'm not just sending dummy data to C++ and getting it back. I'm getting the data from a file that I've saved somewhere on the C++ side. When I get the data back, I can affect any objects that I have in play with the exact data, the position that I have on the C++ side. Guys, this is the first piece that you need, right, to start getting going with this idea of a file loader and a file saver, which is coming up in your game, group project part 2. So recap. Notice what I did. I had to turn Unity down in order for me to rejig the DLL that's inside of my plugin. It wasn't enough for me just to delete it here in Unity. I don't recommend that. I find that there's still a meta tag involved. I've tried it before where I've had to drag and drop, and you get these inconsistent results. So I find just turning off Unity, removing the thing in the File Explorer, and putting it back is more consistent from a performance perspective. I did that. When we rejigged it, I had to do a couple of things here. I had to rebuild my DLL on this side, right, on the C++ side. After I rebuilt my DLL, and only after that, could I pull it across onto the Unity side. Okay. I've also kept a vector2 object that's not in use. It doesn't matter because the only thing that's exposed is inside of the wrapper file. The wrapper file is the thing that exposes the interface, the application programming interface of the things that can connect to my native side from my managed side. Managed being Unity, native being C++. Okay, I'm just going to finish this off now. So this is great. Thank you for that. It worked. I'm going to turn off Unity for a second. I'm going to turn down my C++ as well. Get rid of all this stuff. And then we're going to make a nice GitHub project for you guys so you can get it up online in a second. All right. So, well, what else is there to talk about? Well, great. Now that we've done that, that's fantastic. But we can also look at this thing called the plugin inspector. In Unity, there's actually a thing that allows us to see what the plugin is made for. And you can actually make plugins for different platforms. One for iOS, one for Android, one for Linux, one for Mac. And the plugins have to be constructed specifically for that platform. So they won't work. If you make a plugin for Windows, it's not going to work for Mac or for Linux. So keep that in mind if you're going to make a cross-platform game. And the next thing is, when we manage plugins, when we make this dynamic link library, we have to be very careful how we generate things. Okay, we can do a lot with scripting, but we have to manage it, because if we don't, notice how I have to turn off Unity and turn it back on, because Unity has to re-import that plugin into the plugins folder. If you don't do that, Unity won't know what to do. One thing we can also we've also done right now when we had a struct is we did something called marshalling. Marshalling is the process where we convert one type of data in memory to another type. We had a custom type that we made on the C++ side called vector3d, and we pulled that custom type into the Unity side on the C# side, which is just a vector3, two different types. Even though they match from a memory management perspective, they are not the same. And because they're not the same, I have to somehow deserialize the data that's coming from my native side and serialize it into something that makes sense on the C# side. When I say deserialize and serialize, I mean decode and encode, right? Or encode and decode, depending on which direction it's going, right? And data types there's different kinds. The ones that we can, that are standard, or we'll talk about them as primitive data types, they don't require special handling. Special handling is the marshalling that we're talking about, right? We don't need to use the marshalling if we're going to pull it over, right? And these types, these basic types, are called blittable types because they're just basic types. Floats, ints, chars, this kind of thing. Those are basic types. We don't need to do much for them, right? It's the other types that we have to do stuff. So these are the basic types that we can just bring across from the C++ side to the Unity side, and there is a translation from one to the other. Okay, so a good example of this is if I want to bring over bytes, and we can store data in bytes, right? Zeros and ones. If we can serialize a class in bytes by creating an array of bytes, then I can send them over as chars, right? Or back as chars, right? And we're going to see an example of that with the thing that I was talking about before. I'll show you something that's been marshaled a little differently. All right, so you can also send over one-dimensional arrays as blittable types. Like, for example, if I want to send over a one-dimensional array of integers, no problem. It'll understand how to do that. But if I want to send a one-dimensional array of vector3d objects, no. That is just not good. You have to marshal that. You have to use the interop the system.interrupt library in order for us to translate from one system to another. Otherwise, Unity, C# won't know what those things are, as an example. Here's some examples of that. So primitive data, we've already seen this. We just use DLL Import plugin name, and we can get floats. We can set floats, and we can get data, set data, no problem. As long as it's a primitive type, it looks like this. We've seen this before. And notice that we can pass by reference, not just by value, which is pretty cool. And that's what the Unity access side is going to look like. There's some examples from previous times. Here's one-dimensional arrays, right? I make a one-dimensional array on the Unity side. This is the Unity side. And I can fill an array, as an example, with data. I can send the array over, as an example, to the DLL, right? So again, it would be like, here's my external int fill array private, and I pass in an array of integers. Look at that. I'm passing an array of integers from Unity over to C++ in this example, right? And I can also get it back, right? I get back an integer. Integer might say did it work or not, right? So that's how it can work. Okay, pretty straightforward stuff. Enums work exactly the same way. Here's a C++ enum, no problem. And on the other end, on the C# side, right, what we want to do is we want to get the day of the week, right? We want to use this, and so we can do the same thing with no marshalling. We can use a DLL import, and we can just use an extern weekday. We define what the weekday is. There's just a bunch of ints at the end of the day. That's what an enum is. So because int is a basic data type, we can transform or transmit enums, enumerations, from the C++ side over to the C# side, no problem. And the same thing goes with, and it shows you how to do that here. The same thing goes with structs, which we've just shown you here. All right, structs. So now you have quite a few things. This is kind of the beginning of how you make a vector 3, but you've got quite a few ideas of what to do, and now you've got a few more tools in your toolbox, a few more ways of kind of transferring data from the C# side to the C++ side and back. Hey, let's make this all into something that you can use. So remember that tonight or tomorrow night, I want you to submit up on Canvas. I have a couple of things to submit. I have an in-class exercise 2, which is a bonus. This bonus is your completed Unity and C++. You can use 2 GitHub repos if you want, or you can use 1. Let's see how we can use 1. Well, they're both turned off, so hopefully we'll be able to do it. What I want to do is I want to go back into my code here. So this is my C#, my C++ side. Okay. One thing to note, whenever I put things up on GitHub for C++, is I want to kill my garbage files. So I'm going to go into my garbage files in the VS folder and then get rid of my database files. These things are massive. These things will make my files 5 megs more. So let's kill all this stuff. So delete all those things. Now, if it's in use, because right now I've got my my stuff working, it's okay. We can copy it across and then kill it afterwards. What I mean by copy across is that if I go to here, here's my native plugin. I'm going to copy this whole thing. I'm going to go into the Unity side of things. And somewhere inside of my package, I'm going to make a brand new folder. And we're going to call it native C++. And we're going to bring that folder, a copy of that folder, in here. Now, I have no problem going to my .vs folder and deleting the files that I don't want because they're not in use. And the IPCH folder should go too. The other thing that should probably go is any executable. That's a waste. So again, inside of my debug folder, there's nothing there. And inside of my debug folder in here, I see that I have some stuff that I can get rid of. So just all I'm doing is cleaning up my files and getting rid of all the garbage files that I don't need. For example, all this stuff. I don't need all this stuff because this is like executable stuff. So I can just get rid of it all. I can probably get rid of all those folders too, but let's just get rid of the stuff that's inside of them. Okay. Again, this is just a copy of my files, right? So it's not going to hurt me. Even this, I could probably get. Well, no, I can't get rid of all this. This is my code. And inside of my release, I have my DLL. I want to keep this because I want to send my DLL upstream. And it's pretty small. Look, my DLL is 11K. 11K, guys. It's nothing. And my PDB file is 564K. So the whole thing is pretty small. So I'm not really worried about this one. Debug mode 2. I can leave that the way it is. I'm fine with it. All right, so cool. I've got my lesson, my native C++. I've just got it here inside of my Unity. So it can all go in one big blow up to GitHub. That's what I'm going to do. All right. I'm going to use some native tools here. So command prompt. And I'm going to go into that folder by dragging and dropping into the Unity side I'm talking about now. And you can see that I've got all that. Now I'm missing my my Git Ignore file. So I'm going to do it. I'm going to add a Git Ignore file in here. So again, on the Unity side, I'm going to add a Git Ignore file. Always do this. Otherwise, you're going to have a bunch of stuff you don't want. So right click. I'm going to add a new text document called Git Ignore. Git Ignore. Right? And I need to fill it up with stuff. And we can get examples of our Git Ignore file up online. So again, I'm going to go up online to my GitHub repo for Ontario Tech. Let's go to Ontario Tech U, see if that's a thing. Sure, I got my bullet pool demo. No problem. That's not what I want. I want github.com and I want Ontario Tech University. Yeah, and there's lesson 1, right? So remember, lesson 1 probably has a Git Ignore file. And look at that. There's my Git Ignore file. I can just steal that back. So I'm going to copy all that. I'm going to go back into my local files here and paste. Now, I got to be careful. And this is before I started my GitHub repo. I got to be careful because, like I said, what the Git Ignore file does is it ignores certain things. For example, it's ignoring my debug and release folders. This is a Microsoft-based, Git Ignore file. It's not ignoring, everything. It's ignoring all Microsoft stuff, right? For Visual Studio, this is not the right Git Ignore file. Nope. Nope. No. I don't want this one. I want one that's for Unity. That's one I really want, right? The one that's for Unity. So how do I get that one? Well, you can make one. Let's make a temporary file, right? If I was to do that, if I was to make a temporary repo here, if I make a new repository, let's make the new repository public, and under Ontario Tech University, let's make a thing called temp. Okay? Doesn't matter. Public. And I want a Git Ignore file. You can specify which type. For example, we're going to specify Unity, right? So if you look at Unity, that is a Git Ignore file made for Unity. So it skips the library files and all that stuff. I don't have to make it for myself. You can also look it up online. Instead of temp, let's just call this like Unity Ignore, so we know we can use this again at some point in the future. All right, and I'll press enter. There it is. There's my Unity Ignore file. Now this is different. See how it doesn't have the library files in here or the build folders, because my library folder is massive and I never want to put that up on GitHub. So again, I'm going to click raw, Control A, Control C, go back down to my files and paste them in. So that's my Git Ignore file. Now this is good. Save. And now that I have my Git Ignore file in there, again, you can do it different ways. You can see that's there and it's not empty. It's 2K. Now I'm going to do my commands in my command prompt. Git add dot. Git, how about this? Git init first. Git init. Git add dot. Oh God. Git commit -m initial commit. Okay. Now I need a remote. And I need to make that up online. Let's go up online and make that together. So I'm going to go here. And I'm going to go to my repository for Ontario Tech University and make a new one. New repository. We'll call this repository INFR3110 F2020, and it's going to be lesson 4 in class exercise 2. Okay, so we know what that is. Okay, you can name this whatever you like. And then I'm going to grab the last 3 lines of code here up online. It gives me steering directions online. I'm going to grab these last 3 lines of code, go back to my command prompt, and right click. And if I press enter and I've configured my system properly, it's going to push everything up to GitHub for you guys. So you'll have everything that I've just done on GitHub. You can download the project, try Unity out. It might even include the DLL. Let's take a look. So if I refresh now, you can see that assets, does it include my plugins? It does. So you can actually download my project right here from Ontario Tech University. Let's grab this link. Let's grab this link here. I'm going to go up on Canvas for you, and you have it for yourself. Okay, so you don't have to worry. You can check my code with your code. Right? Again, what I want is a URL. Here's my URL. And my page name is going to be called GitHub repo for week 4. That should be clickable. Let's try and see if I can get that. And oh, I don't like when that happens, right? That's a Canvas thing. Let's see, does it actually make it in? Oh, okay. So you have to make it in a new tab. Okay, let's fix that. Problemo. We don't want that to happen. Let's modify that, and we'll make sure it loads in a new tab. And then if I click onto it, it should work. Yes, it does. Awesome. So now you have everything. You have the native C++ example right here. The entire folder, right, is in here, and then you have everything else in Unity. Okay, so the entire example. Okay, I know it's a lot today, and I was going to do design patterns, but I'm going to stop recording right here. I may include an addendum, right, for design patterns on the weekend. That's tomorrow, just to help you guys with additional information for your assignment. So that way you don't have to do a lot of research on your own, because I want to help as much as possible. I did plan to put up a document for design patterns. I just couldn't get around to it. There was so much to do, and I wanted to make sure you had your DLL because you need it for next week for your midterm test. Okay? And you're also going to need the design pattern stuff, so I'm going to put that up online and talk about how to do that. I think I'm going to probably record that tomorrow, okay, as an additional thing. So you have extra information for yourself so you can get going. Also, next week, one thing to note, going back to our project here, please, please, please do not miss what we talked about before. Do not miss hanging out with Nick on Wednesday of next week, because on Monday we're going to release the test, and by Friday it's going to be due. And again, just to repeat, next Friday there's no formal lesson. I'll be here during this time frame to help, but there's no formal lesson in terms of what you need to do. Like, you don't have to watch me do stuff. It's just me answering questions. Think about it as office hours. I'm offering office hours so that you and I can get together. I can help you with your problems. I can help you with group assignment part 2 and all those kind of things, so that your entire experience is as best as possible. That's what I'm hoping. I know there's a lot here, guys. And you know what? I know it's not easy, but hopefully some of these, some of the videos and some of the things we've done together today, like a little tutorial we did today, helped. Okay, I'm going to stop recording, and then I'll take questions. Hopefully you guys have some.